Hey everyone, so in this video we're going to take a look at the updates to my trap-based tower defense game. So I decided to move forward with the advanced power management. So now capacity, load, and then the brownout and blackout status is all lane based. I thought that doing this would make the game harder. In some ways, it makes the game easier because before, if you had a brownout or a blackout, since there was only an overall capacity and load for the entire play area, then your entire play area would go to a brownout or a blackout. Now, because it's lane by lane, one lane can be a brownout, one lane may be a blackout, and the other lanes might be just fine. So it makes the power management a little bit more advanced, but also results in a more forgiving scenario. Okay, so let's take a look. So I also added a delay. So whenever you install anything, this is a delay before you can install anything else. So if I click here, you can see we have the typical kind of timer going on, and then it tells you that you're ready. So if I click on another one, I'm rapidly clicking here and nothing's building because of that delay. Same thing for a trap. If I place a trap and I try placing here, nothing's happening. As you can see, the traps build faster. And what I need is to exceed a certain amount. As you can see, there's lights now. I mentioned that in the previous video that I was going to add lights. And as you can see, now that we're in a brownout condition, you get a yellow light alerting you that there is a problem. So what will happen now is because of this condition, it will take longer for these to reset. I believe it goes from a 1-second reset to a 6-second reset. The only way to really see that, though, is to have two zombies right next to each other. And then if I keep adding, now you have a blackout condition. So when he steps on this, nothing should happen. See? So it's blacked out. So this is not working. I still don't think this is quite salient enough. I'm not quite sure what more I can do. I don't want to really have the entire lane be shrouded in, say, like a dark black or something. I don't think that would work. I think that would look odd. But at least you now have this trap indicator, whereas before all you had was indicators over here. Okay, so I think that that's about it for the power management. I'm going to show you the code now. Let me just think. So one other thing I want to mention is that because of the power being divided by adjacent lanes, you have this interesting dynamic where not every lane has the same amount of power. This lane and this lane, so second from the right and second from the left, will have the most power. The two center lanes will have the second most power, and then the end lanes will have the least power. Because again, generators are giving power to the adjacent lanes. So what happens is one of the things that I could do is possibly have a level where there's a lot of enemies coming along the side, even though those are the weakest. You'd have to somehow use power from these lanes to do damage off to the side. So maybe there'll be a trap that faces in different directions, and so the trap is here, but it's meant to damage over here, that kind of thing. So get into that type of strategy because again, I don't want it. I don't want there to be functionality if it doesn't do anything. I don't believe in functionality for just its sake. It should give some kind of meaningful gameplay. Okay, so I think that as far as the actual playing, that shows you the updates. So we have the generators, we have the timer, we have the lane-based green, yellow, and blackout conditions. Okay, so let's take a look at the code. So it's a little bit much to go through in one tutorial, so I'm just going to hit the highlights, and that is, in short, this is handled by arrays. So an array has multiple positions, okay? Each position in that array will refer to a lane. So we have lane capacity, that's self-explanatory, lane load, that's self-explanatory, and then the blackout state, again, per lane. So this is the 0 position, because that's how computers count. I don't use that one. So there are 6 lanes, but there's 7 positions because I want to use lane 1, lane 2, lane 3, 4, 5, and 6. Okay, so these positions indicate the capacity for the corresponding lane. So as you add generators, these get increased. As you add traps, these get increased. And then there's just a comparison that says if this is less than this, then it's a green status. If this is less than this, then the traps on that lane have a yellow status. And if this is greater than this by, say, 50%, now it's a blackout status. And how do I handle the blackout status? I just disable the collider. So no collision is occurring. So it's a very simple way to create a blackout condition. And then if through whatever means this is no longer being exceeded by 50% and you have to reverse the blackout condition to a yellow or to a green, then what happens is the collider simply gets re-enabled. And as you can see, there's a blackout status. So this just gets changed from G to BR to BL, again, based on that calculation. So I don't want to go too deep into it because some of this, it should not be memorized. It's just the broad strokes because some of this only works because of certain attributes of where positions are, and I'll get to that in just a minute. But in general, this is what's handling the lane by lane green, brownout, and blackout conditions. So we're just having a loop between 1 and 7. 7 doesn't get executed. So it's 1 through 6. And what I'm saying is those variables that we just looked at. So if lane load 1 is less than equal to lane load capacity 1, then blackout state 1 is green. Rinse and repeat for 2, 3, 4, 5, 6. Don't mind this. This is deprecated code. Whenever I'm transitioning from one system to another, I keep the old code just in case, and then I delete it. So again, starting with rep 1, if lane load 1 is greater than lane capacity 1, then blackout state is 1. Blackout state 1, excuse me, is BR. So this is turning that into BR. So whereas this is green, it would be BR. But then it checks one more time. If lane load rep is greater than or equal to lane capacity rep times 1.5, it's arbitrary. I said if you exceed 50%, well, 150%. So if you exceed capacity by 150%, then you get a blackout. And so again, blackout state rep is equal to BL. So say this is up to rep 5. Lane load 5, if it's greater than or equal to lane capacity 5 times 1.5, then you have a blackout state for rep 5 set to BL. And then the last thing is the traps making decision based on this status, because again, each trap will be based on the lane. So how do I make the trap realize what lane it's in? This was actually a happy coincidence. So because I positioned the lane evenly, I can take their X position and convert it to an array position. Because again, the array counts 0, 1, 2, 3, 4, 5, and 6, with 0 being ignored. So I just have to convert the I have to convert the X position of the trap to a corresponding lane position. And again, like I said, this was a happy coincidence. So if you click on these, you'll see that, and these use the same positioning as the trap lanes, okay? -4, -2, 0, +2. So you see the pattern. It's an increment of 2. So what happens is if I can convert that to 1, 2, 3, 4, 5, 6, so if I can convert -4 to 1, -2 to 2, 0 to 3, if I can do that conversion, then I can just use its X position to refer to a lane number, which is an array position. How do I do that? Well, on the individual trap, I create an int, because if you are using a number to identify a position in an array, it has to be an int. It cannot be a float. So I'm going to say lane X. And the reason why I call it lane X is because I'm taking the X position and converting it to a lane number. So let's solve this from the inside out. So lane X, it's going to be transform.position.x. So again, that X position that we just looked at, -4, -2, 0. We add 6 to it. Why? Because I need them all to be positive. So -4 becomes 2. -2 becomes 4. 0 becomes 6. And now, if I divide that by 2, -4 becomes 1. -2 becomes 2. 0 becomes 3. So this is important to understand. This equation only works because of the positioning. So I don't want you to memorize this equation. I want you to understand the logic. The idea that I took consistently placed and positioned objects and turned it into something entirely different. I turned it into the corresponding lane that they are in. And then just the last part of this is mathf dot round to int. Don't be intimidated by this if you've never used this. This is just saying that you're going to use some kind of mathematical function, and this is the mathematical function that you're using. Because again, if you want to refer to a position, you can't use a float. You have to use an int. You're saying, I want position 1, position 2, position 3, position 4. It cannot be a float. It has to be an int. And so that's what this does. It takes that float, because this is a float, and it converts it to an int. And so now I can use this to indicate what position in the array I'm going to use. Because here, if you remember, I was using the rep int. So now I'm going to use the lane X int. So this is the update section. So this happens with every frame. With every frame, the trap is going to look at its position, so which lane it's in, and it's going to see if that position in the array is set to green, brown, or black, and then make a change correspondingly. So if blackout state, again, blackout state was set here on a lane by lane basis. So here you're going to say if lane X, so again, this has been converted to 1, 2, 3, 4, 5, 6. So if the blackout state for the same lane that this is in, because that's really what you're doing here, rather than using, we are using an if statement, but what we're saying is we're converting our X position to a corresponding lane, which is a corresponding position in an array. If that is set to green, then don't worry about this. That's a separate explanation. But we want to make sure that the box collider is enabled, because as I said, when it's blacked out, it's disabled. We want to make sure that there's no additional delay for the blackout. And this is a private variable. So that's why this is not an array. This will be handled on a trap by trap basis. And then we just change the light material to a green material. OK green is just the name of the variable that I used. It doesn't actually make it green. It's the variable refers to a material that is green. And then just rinse repeat. If blackout state for the lane that this is in is set to BR, then go ahead and use the yellow trap, and there is now a delay due to it being in a brownout condition. And then last but not least, if the position in the array that corresponds to the position that this trap is in is set to BL, and this is what I said earlier, we just disable. We make the box collider not be enabled, and therefore no collisions can happen, and now we're using a red material. Could I have technically done this with code? Like, rather than having 3 materials, I could have had a white glowing material and then just changed it to green, yellow, and red. Yes, but it's kind of a pain. It's kind of obnoxious. Depending on what, if I recall correctly, depending on what renderer you use, the coding is slightly different. Like there's emission underscore color and emissive underscore color. And I think it changes depending on the renderer. I'm not 100% sure. I didn't feel like going through all that syntax, so it's easy enough just to swap between 3 materials. And let's just see how this is used. When a trap is triggered, it goes to the trap routine. And in short, what happens is, I'm not going to go through this, but the bottom line is this is the part in which the trap gets reset. So it's normally 1, and if BO delay is 0, then it's a 1-second delay. By changing BO delay to a 5, this now becomes a 6-second delay. I'm not saying that's the right amount. It was just made it very easy to determine if it was working. Again, this is definitely not an introductory. This is much more advanced because I'm not going through every little thing, explaining every little thing, but that tends to be what these dev logs are meant to be. These are meant to be more intermediate or advanced tutorials. So I'm showing you in real time how I'm working on the game. Hopefully you derive some usage out of it. But that's where we are. So yeah, I know it probably seems like it's been a lot of time, but I've kind of been in very low gear mode lately. So I've only worked on this for a couple hours per day for a couple days. So I'm really happy with how quickly this came together. And now that I've got this, I think I'm ready to move forward with the game to get into full production of it. So I'll probably purchase additional assets for additional levels, additional enemies. I'm targeting maybe 18 different enemies. We'll see. We'll see what's practical and as far as getting models that have a similar visual style to them. Anyway, so I think that's about it. I hope that you found this useful, and please do enjoy the rest of the day. And please have a happy new year, and that should about do it.